What we're going to do is we're going to look at how radians and degrees are related. But before we do that, we're going to look at coterminal angles. And what we have is we have our coordinate system. And with the coordinate system, what we do is we start at 0, and then we go 90, and then we go 180, 270, and then back to 360. A coterminal angle will be an angle that's in the same spot, but it depends on how many times you go around. You could go around once or twice. You could go around the opposite way. Each one of those, if it lands on the same line, that would be a coterminal angle. So what we're going to do is we're going to name another coterminal angle. Now what I'm going to do is I'm going to give the positive and the negative version. So remember, we talked about it being going around is 360. So either we're going around 360 in the positive direction or we're going around 360 in the negative direction. So when we're looking at 46, we could either add 360 or we could subtract 360. If we add 360, what we get is 406. Or if we subtract 360, what we're going to get is negative 314. Either of those answers work. I'm just putting both of them so you can see what the positive is and what the negative is. But you just have to state another coterminal angle. In the same way, if we have 385, what we're going to do is we're going to add or subtract 360. So if we add 360, what we get is 745. If we subtract the 360, what we get is 25. And either of those is correct. Now, what we're going to do is we're going to look at radians. Now, radians are the same as degrees. It's just a different unit. So instead of 360, what we say is 2 pi. So when we're going around, what we have is 0 radians, pi halves radians, pi radians, 3 pi over 2 radians, or 2 pi. And that's how radians work. So for this one, we're either going to add or subtract 2 pi. This is a little bit more complicated because we need a common denominator. So we're going to take the 2 pi over 3, and what we're going to do is we're going to add and subtract, and we're going to take the common denominator, which would be 6 pi over 3. So if we add it, it would be 8 pi over 3. If we subtract it, what we would get is negative 4 pi over 3. And those would be our two coterminal angles. Once again, you just need to state one of them. In the same way with letter D, what we're going to do is we're going to add or subtract 2 pi. We're going to find the common denominator. So that would be 5 pi over 2 plus or minus 4 pi over 2. If we add, we get 9 pi over 2. If we subtract, what we get is pi over 2. And those would be two coterminal angles. Now, obviously, there's more coterminal angles, but those are just the two basic ones where we add or subtract. In like this first example, we could add or subtract 720 because that's going around twice. And then in similar situations. Now, for converting radians to degrees, what we're going to do is we're going to use pi and 180. The reason that we're using pi and 180 is because we could use 2 pi and 360, which we already talked about. But if we divided each of those by 2, it would reduce to pi and 180. So that's why we use 180 and pi. So when we're converting it, what we're going to do in order to turn degrees into radians, we multiply by pi over 180. What this does is it takes away the degree and turns it into radians. So 45 goes into 180 4 times, and so our answer is pi fourths. If we change 100 degrees into radians, that would be pi over 180. The zeros cancel. That would be 10 pi over 18, and that reduces to 5 pi over 9. And then for our last one, if we take the 210 times it by pi over 180, zeros cancel, and what we get is 21 pi over 18. And then we reduce it by 3, and that gives us 7 pi over 6. Now, looking at example 3, this time what we're going to do is we're going to take the radians and we're going to convert it into degrees. So that means that we're going to times it by 180 over pi. This time we're taking away the radians, and we're going to times 3 by 180, and then we're going to divide it by 4. And that gives us 135 degrees. So for the next one, we're going to times it by 180 over pi. The pi's cancel. 2, of course, goes into 180 90 times. 3 times 90 is 270. And then for our last one, what we're going to do, once again, we're going to times it by 180 over pi. The pi's cancel. 5 goes into there 36 times. 7 times 36 gives us 252 degrees. So some stuff to remember from Algebra 1, adding square roots. This would be 1 square root of 2. This is 3 square root of 2, so that would be 4 square root of 2. For the next one, we have to simplify 27. And in order to simplify 27, that would be 9 and 3. And the square root of 9 is 3. So that would be 7 square root of 3 minus 3 square root of 3, which would be 4 square root of 3. And then for the last one, we multiply. 4 times 5 gives us 20. 2 times 6 gives us 12. And we know that 12 is 4 and 3. Square root of 4 is 2. 20 times 2 gives us 40, square root of 3. And for our last one, what we're going to do is add our like terms. 3x plus 2x is 5x. Negative 5 plus 3 is negative 2. Here we're multiplying them, so we're going to FOIL. 2x squared minus 7x plus 10x, and then minus 35. Here we have the like terms, so 2x squared plus 3x, and then minus 35. Now, letter C, whenever you're squaring it, you write it twice, 3x plus 5. Then we FOIL it, so 9x squared plus 15x plus 15x plus 25. And that gives us 9x squared plus 30x plus 25.